My name is Annette Tabor, and I am the Vice President of Industry Outreach here at CompTIA, and I oversee 5 industry advisory councils, including our Smart Cities Council, who's sponsoring our webinar today. Before we get started, I'd like to couple a couple of things. First of all, for those of you that don't know, many of you may not realize that CompTIA is the Computing Technology Industry Association. We've been around 42 years. We are a not-for-profit, and you should think about joining. There's a lot of benefits, access to influencers, education, research, policy team on Capitol Hill. We have our philanthropic arm called Creating IT Futures. We have 10 communities that you can get involved in, and we'll talk a little bit more about that at the end of the presentation. But here's a list of some of the benefits, including 15% off CompTIA certification vouchers. We are the second largest certifying body in the world behind Microsoft. Many people don't realize that. We have over 2 million certified alumni with another 250,000 that we certify every year. So we're going to go ahead and get into our topic, and I'm really pleased to introduce with you today Peter Murray, who sits on our Smart Cities Council. He is the executive director from Dense Networks, which is a cross-disciplinary social think tank focused on cloud, mobile internet, big data and analytics, as well as IoT, which is our topic today. So Peter, welcome, and I know you'll be introducing our esteemed panel, so let's just go ahead and get started.
Thanks, Annette. It's been a pleasure to be part of the Smart City Council group within CompTIA. The best part about that is I've met quite a number of really smart people and gained a little bit more in my network. So that's very important. Dense Networks, as you mentioned, we focus on smart cities and connected cities specifically. We look at how the ecosystem of the network and densification are beginning to impact city services. We've done a number of events around the country. You can switch to the next one. We've gone into a number of cities. Here's a slide from the city of San Jose. And one of the key takeaways as we move to 5G, IoT, and some of these advanced services is the importance of the infrastructure of the city, the physical infrastructure. And as you can see here, San Jose came to the conclusion that the light pole was critical to their deployment of broadband and connectivity. Next slide. I won't go into each detail here, but if you look over to the far right, Justin Bean from Hitachi will be presenting towards the end of the seminar here. But if you look, you see the video camera, you see the full deployment that's required to create smart cities, connected cities, and smart spaces. Next slide. And this was from City of San Jose. We looked at, we did an event in Orlando, and this is from the Smart City Director in Orlando. He talked about how the importance of the electrical upgrades and LED lighting is, and if you look down the list here, you can see a number of the other areas that they plan to address and have addressed as they've deployed new light poles and new LED lighting. Next slide. City of Boston. Again, collaborating with a number of companies, including Verizon. David Tucker is going to be speaking a little bit. But the light pole, again, becomes really crucial to IoT deployment and deployment of 5G and small cells. Next slide. Here's a slide specifically looking how small cells should be deployed. And this is a cooperative slide from the Excel utility and the city and county of Denver that collaborated, again, with Verizon and a number of other companies. A smaller company that's doing quite a lot with smart poles is called Comtech, and I believe they helped build this design. Next slide. And then last slide. This is a Verizon slide. They presented at one of our events, or actually a couple of our events, and here again they show the full vision of utilizing the light pole. So next slide. And here you see mentioned densenetworks.com. We have a full list of our events, but we'll be in Miami, Tampa, Denver, and Las Vegas. So that said, David Tucker from Verizon is going to be our next presenter. David?
Hey there. Thanks, Peter. So why don't you go ahead and to the next slide. So I'm David Tucker. I'm head of product management for Verizon Smart Communities. And Verizon Smart Communities, just a little overview, is a division within Verizon that is focused on bringing the assets and capabilities and technology sets from across the Verizon portfolio, whether it's the fiber or access capabilities through to the applications and managed services stack to address the needs of cities and help them build communities that are enabled and focused on, becoming connected and becoming a smart city over the course of the next few, currently, and then over the course of the next few years. And some of those that Peter mentioned, San Jose, and others are some of the ones that we're working with in a number of different ways to help build that out. And go ahead to the next slide. As we have engaged with cities, really, there are a number of city initiatives that have come to the forefront as the needs of these smart cities. And this is working with departments as well as CIOs of those cities, or the more innovation centers as well, that are trying to bring cities together to more holistically across department. But really, if you look at the mayor's needs and the department officials, it's really kind of buckets down into what we think of as these three categories: improving sustainability and efficiency of that city, in reducing crime and increasing the security, and then enhancing the overall citizen experience, whether that's crossing the digital divide or just through better reduction in traffic and other types of things within the city. So core to all of that, whether it's IoT or 5G, IoT, LTE, 5G, is the connectivity aspect of turning a city into a smart city, and the data that goes along with that, capturing that data and acting on it, and turning your city into a smart city. So if we go to the next slide. For Verizon, we've been building out our LTE infrastructure for a number of years and improving that constantly, and that's really the core of our assets, is the fiber that supports that, and the billions of dollars that we've poured into each of these communities to service our existing customers through LTE. Go ahead to the next slide for me there. And that has resulted in one of the largest, most highest quality networks in the 4G community out there in LTE, that has really given us that that breadth of coverage. And then as we look at using that as the foundation for smart cities, we also get into the need for 5G services. And go ahead to, rather than me talk, why don't you go ahead to the next slide, and hopefully you can play the video there and you'll get a sense of what we're doing. Is there sound on that?
Mike, we need sound.
There will not be sound due to playing from the PowerPoint, so I do apologize for everyone.
Sorry, is there sound on the video?
David, it did not sound like they're going to be able to get the sound to come through on the broadcast here.
Okay. Well, so I guess you'll have to listen to me talk then, unfortunately. But what you're getting a sense of is the actual deployments that we're doing within cities, and some of our first trial test beds for both residential broadband as well as fixed wireless for other city services. So we've deployed in our test beds in a number of different cities, and we're going to full rollouts in a number of different places. And we'll go to the next slide, and you'll be able to get a sense here. So we also have, I guess I'll talk through this. We also have a tech alley where we've been working with incubators on 5G and testing out 5G services in real world, from streaming services. We've also been in, over the last period of this last couple of years, been in M-City, doing test beds with mobile vehicles and understanding the capabilities there. And as we build out 5G for the future, there's a number of segments where we see it becoming very critical. And so getting the experience in these different test beds has been critical to our success and our plans as we build that out. Why don't you go to the next slide, and we'll skip over this since it's really just watching fun folks doing deployments in the real world. Great, thanks. So, as we've announced at Verizon our 4 key markets where we're rolling out right now: Sacramento, Indianapolis, Los Angeles, and Houston. We have a very large investment in fiber and the fiber build-outs to support those 5G networks, which is really critical. And that supports both our densification of 4G and rollouts there through LTE and LTE Advanced, but it also gives us the capability to provide 5G services in a broad set of markets as we build out the capabilities. And I want to touch on just a couple of things that 5G is not just an evolution of 4G. It really is a true new network build. The levels of densification that are required for 5G services are much higher than anything that we've seen in 4G, and even in densification of the 4G networks for service of markets. We're talking about very localized, need for very localized radio deployments. I'm sure many on this call know that. But that is where, in the 5G space, that is where the light poles come into play. And light poles come into play not just for densification of the network and deployment of that network equipment, but it also comes into play for the provision of smart city services, which is where we in smart communities have been very focused. One of the other aspects of that 5G network deployment that I want to touch on is planning for the intelligent edge. And this is really, a lot of, in the industry, the term mobile edge compute is really the ability to send compute out much closer to the edge of the network where the devices are. And that MEC, or that mobile edge compute, the edge of the network there, is going to open up a whole new set of use cases in smart cities across mobility and public safety in ways that we haven't seen before in the industry, in terms of connectivity and the compute capabilities and really distribution of that compute closer to the edge. So go to the next slide. So just to give you a sense, I think this is just illustrative of 5G, and one of the things that is, the most obvious use case scenario, which is the download kind of function and the higher throughput of 5G. The ability to go from, a 4G 100 megabit connection where you're downloading something in, minutes to seconds, or a blink of an eye, in terms of the capacity and the bandwidth that is coming from that 5G connection. That opens up whole new worlds in terms of distribution of content, which is the most obvious use case for us, especially as consumers ourselves, in terms of consuming content through 5G. Excuse me, I have a bit of a cold. But let's go to the next slide. So just to give a sense of where some of the technical, expectations of 5G are going in the longer term, I'm not going to read all these to you, but I do want to touch on a couple that I think are key and critical to opening up use cases, both, around the smart cities in particular. Peak data rate. So, getting into the 20 gigabits per second range. I think near term in the 2019, 2020 timeframes, really we're in the 10 gigabits per second. But that amount of throughput and bandwidth is just going to really change the game in terms of the content consumption. But it will also change the game in terms of the symmetric nature of 5G. So we're no longer talking about just download speeds in that range, but we're also talking about upload speeds in that range, which will really dramatically open up new use cases in terms of interaction with between us and compute or cloud applications or things, in fact, the infrastructure even around us. The other aspect of 5G that is critical is really the latency component. So as we look at latency that gets into single-digit millisecond latency versus, you know, what we've come to typically expect in the tens of milliseconds or even hundreds of milliseconds range, or in, you know, some applications, seconds of sensitivity in the latency side of things. But being down in that single-digit, 1 millisecond type latency range, then begins to open up use cases in mobility, infrastructure, in ways that we have never seen before in real-time nature of those services. Go ahead to the next slide for me. So really, as we think about 5G and its impact on how we provide services both to cities and consumers, we really tend to bucket it into these 4 categories. And so, you know, on the upper left here, high bandwidth download, video streaming, the ability to get content out to the edge very quickly, opens up doors and opportunities in terms of virtual reality or augmented reality use cases that you know, will enable both on the consumer side as well as industrial or commercial side of things, new use cases to enable use of content in ways that we haven't seen. And that comes with also the latency, the low latency aspect of that bandwidth streaming also comes into play there in terms of interaction with that augmented reality. On the lower left, however, in that category is the high bandwidth upload. And to me, this is really one of the big game changers, especially in cities and in public safety in particular. The ability to now utilize that 5G network for streaming video, for surveillance opportunities for the police department, for real-time situational awareness in places where they hadn't previously been able to get connectivity or to be able to get that real-time nature of video. That is really a huge game changer for 5G in the public sector and police departments in the surveillance space. Switching over to the upper right, that low latency component, this is where we see huge use cases and opportunities opening up in terms of V2X and connected vehicles, the telematics space, and being able to open up navigational and autonomous vehicle communication that goes really effectively across the city. So rather than an autonomous vehicle or even, you know, for that matter, you and I being out there as a single driver on the roads, you know, only knowing what's going on in our visual range and what we can actually see, we would be able to, in real time, be communicating mobility information for a large, or, you know, a area around us or around our vehicles, and having an interaction between vehicles and infrastructure in real time, and so much so that it can help us navigate or help us avoid safety situations, or even help autonomous vehicles in that same type of situation. That low latency aspect and bidirectional communication is really going to be key in the mobility telematics space in terms of that V2X communications. And then, excuse me, on the lower right, this is really where we get into some of the more IoT, traditional IoT types of technologies that we've been, been experiencing and deploying through LTE today or through CAT-M types of technologies. But with that, with the higher density and more scalable network, and with that lower latency, comes the ability to deploy devices and deploy sensors and data collectors at a higher density than we've ever seen before. And with those devices being on the network, and being able to communicate very efficiently and effectively, they can last a lot longer out in the industrial or city environments. So we'll see longer battery life for battery-operated sensors. They'll be able to come on the network and send data very quickly and efficiently, and then jump off, saving battery life, and so extending the life of those vehicles, which then makes infrastructure deployments even more viable for cities when you talk about the extension of that ROI into beyond the 5-7 year time frame into more of the 10-15 year or plus time frames. So that will be a huge benefit to the smart cities infrastructure and deployments as well. Okay, if you can go to the next slide for me. So,
and David, we're going to need to leave a little time for questions at the.
No problem. I'm just wrapping up here. We'll do it really quickly. So really, just to reiterate the point, so at Verizon, as smart communities, we're really focused on these three categories: improving sustainability and efficiency through cutting emissions and improved lighting efficiency and improving traffic congestion. The next slide, please. Great. And then reducing crime and increasing security. This is, again, where I see huge changes to the industry in terms of the public safety sector. On the next slide. And then overall, enhancing the citizen experience, crossing that digital divide, opening up broader use cases for our communities as a whole to interact through the connectivity side of things and information at a very local, hyper-local level. Okay, and Peter, over to you.
Thanks so much, David. Next speaker is Matt Walsh, Director at AT&T in the IoT Solutions Group. Matt?
Yeah, hey, good afternoon, everyone. I appreciate the opportunity here to present. And if you want to move to the next slide, we can just jump into the agenda really quickly. I'm going to talk through today our path to 5G, just give you a little level set on how we get there, talk a little bit about the capabilities that will come with that, and then how that will translate to devices, and then what some of the smart city use cases are. And then if we have time, and we've got to accelerate through this, but if we have time, we'll talk about some of our current efforts. So my responsibilities within AT&T are focused on a few different segments of business, all of which benefit from the 5G deployment. Smart cities is certainly one of them. I have drones, utilities, and then everything for public safety when it comes to IoT. In the smart city space, we really have been focused on finding the right products and solutions that AT&T brings forward, and then curating solutions that our partners offer. And a really great example of that is digital infrastructure with the offering that we have with GE Current offering their City IQ node, bringing a multitude of sensors, bringing forward cameras, microphones to bring solutions that increase public safety, that increase the citizen experience, and those capabilities are on our network today, things that can be delivered today, but that will be enhanced through 5G. So with that, we'll jump into the presentation. Maybe the next slide. Yeah, so when you look at the capabilities for 5G, we really kind of bulk it down into 5 different categories. So there's massive device connectivity. So if you think about it, today there's 20 million devices on a network, but being able to scale that and support 20 billion devices, but then not just being able to scale it and provide the connectivity for that, but being able to provide it at a reliable rate that just hasn't been provided in the past. So think about being able to deliver it with 5 nines of reliability. So this is the type of connectivity that industry is looking for, that can be relied upon, that can be deployed and depended upon in order to deliver mission critical information. Low latency is super important to this category. As we're deploying 5G and in the test markets that we're seeing less than 5 milliseconds in latency. So in a lot of the tests that we've done in real world environments for 4G LTE, that latency can range from 80 to over 100 milliseconds, and then to get down to 5 milliseconds is real world, real life experiences that we're seeing today. And then better capacity and coverage. And then obviously I think what's driving a whole lot of interest about this category is what's happening in the speed space. And so, you know, supporting speeds up to 20 gigabits per second really, I don't think people can really comprehend the use cases and what will come from that type of capability, but we'll talk about some of what we're thinking about today. Next slide. So it's an evolution, as I mentioned, and you know, we've announced 12 different cities that we'll deploy, you know, in portions of here by the end of the year. We'll have a map that'll walk through those, but you can see how we've stacked from, you know, all the way from 2G to, you know, eventual 5G deployment. And, you know, if you look down this path, each one of these, you know, from LTE-A, you know, the 5G evolution, and LTE-LAA, which is where we're combining unlicensed spectrum with licensed spectrum to deliver, you know, up to a gigabit in speed. So we have in 24 markets, we've got LTE-LAA deployed, over 400 markets with 5G evolution, and then building on top of that, an eventual 5G full deployment. Next slide. So we talked a little bit about the cities. So these are the cities that we'll deploy in this year and next year. Those that are this year are Atlanta, Charlotte, Dallas, Houston, Indianapolis, Jacksonville, Louisville, New Orleans. I should say Louisville for those that are familiar. Oklahoma City, Raleigh, San Antonio, and Waco. And then we'll extend that to the rest of the cities. We'll have deployments in Los Angeles, Nashville, Orlando, San Diego, San Francisco, and San Jose. So really, you know, a significant number of cities here before the end of the year, but then, you know, an expansion at the beginning of next year. Next slide. So as this slide builds from the left to the right, it really is these four bubbles on the right-hand side, from expanded radio access and edge computing and you know, the flexibility and transport and the, you know, reimagined core that ultimately are going to deliver smarter devices, whether that be an autonomous car with high bandwidth capabilities allowing the rich delivery of sensor-based content or LiDAR, but then also, you know, low latency is going to make a huge difference in the way that the cars are able to communicate and react. You think about the time difference for a vehicle when you're talking about the latency speeds that we're talking about and the time that they can travel, and the difference between those two are significant and can make a difference in safety. And then, you know, Hitachi will be presenting. Hitachi is a great partner of ours, but video-based services and analytics are going to be huge in this category. It's one of the most constrained opportunities in our current environment, and it's really going to open the door for those capabilities. You know, today we use, you know, cameras, and we really view cameras as the IoT sensor of the future, right? And so being able to use a single device that can monitor traffic for you, a single device that can monitor parking and be able to provide information as it relates to parking occupancy, but then also parking violations. You think about, you know, the camera and the analytics tied to that, how rich that can be, and how much more higher definition solutions that you can have that can cover much broader areas to provide that information over. We used, as an example, a camera for an oil services company where we had a gauge that was an analog gauge that they had deployed throughout the field through thousands of sites. They didn't want to replace it because it was high cost to do so. So we put a camera on the gauge, and the gauge is read by the camera and analytics applied, and then we're able to feed that information back. 5G will expand that and allow you to read multiple gauges at one time, a significant panel of information, whereas you're focused today on a low power, low bandwidth video stream. We can move to the next slide. So when you think about LTE, we kind of bulk it into 6 dimensions, and we're very, very focused on not just fixed private LTE, but mobility and being able to have mobile LTE or mobile 5G available And we're testing it, and it's capable, and we've demonstrated it already this year on a mobile device that will be in production next year. So, mobility is key to a lot of the 5G use cases, and you can see how that mobility spreads across these different components and how these different components take advantage of the 5G elements, whether it be battery life. You think about today, if you compare the exact same usage of an LTE device on an E node B with a LTE device that's on a G node B, it takes significantly less power, significantly less energy to transmit that exact same data. So you're going to see extended battery life across devices, whether those be sensors or handsets in a very very normal use case scenario. But then as you start looking at connected transport, the importance of the ultra reliability that comes with that, the importance of the low latency and the high data rate really come forward, and the increase in mobility, the importance of mobility just increases as you move up the stack on this slide. Next slide. So we can go jump into the use cases really quickly. And I don't want to steal the thunder from my friends over at Hitachi, but we really see a great opportunity, as I mentioned, in video surveillance. Certainly that applies across enterprises, but is a solution that we've seen a ton of interest in and that we've got a ton of interaction with in cities. It's a really exciting opportunity, especially when you start looking at the analytics capabilities. It's no longer just about a view of what's going on. It's a view and analysis of that information. Go to the next slide. So this is a topic that's near and dear to my heart. I have the drone category for everything that AT&T would do for drones to enable them. And one of the interesting things that we've found as we've worked through airborne connectivity for drones is that it's simply the network today, as it's built, is built for terrestrial use cases, no doubt, right? And as you elevate and as you go to higher elevations, you can see more towers, and the device, as you're on the ground, really depends upon a dominant server, one dominant tower that serves your device. When the capabilities of the 5G network is going to come with beamforming capabilities that will allow you to connect directly to a device. And a really good way to compare it is the network as it operates today is like a light bulb, and that light bulb can brighten an entire room, right? But you don't necessarily need that light in every element of the room. Whereas with beamforming for 5G, you'd be able to point that bright flashlight on the position that you need and feed only the data that you need to that device, rather than a broad distribution of that spectrum. So really exciting stuff. Obviously, there's going to be great capabilities that overlap with the surveillance space when it comes to drones, because they're, at the end of the day, in a lot of cases, they're just a flying camera platform. We'll go to the next slide. And we talked about V2X, but as vehicles explore a path towards autonomy, an ultra-reliable, low latency network is going to be necessary to enable point-to-point communication to networks. So V2X communications enable both non-network and network-based use cases. These applications include intersection collision avoidance and around corner awareness. So, a lot of the V2X capabilities will, as they exist today without a 5G or LTE backhaul or dependence upon line of sight or very close engagement with another device, but being able to use the 5G network to be able to inform vehicles, inform their operations far beyond that close proximity. And if we have time, we can jump into these real quick use cases. I think there's 3 of them. They're not use cases. This is actually where we've done some demonstrations.
Yeah, Matt, we probably have about a minute left, so feel free.
Yeah, so then how about I just focus on Magnolia, and then we'll move on from there. So this is one of the tests we did in Waco, Texas. Oh, sorry, one slide back. Yeah, and this is a test we did in Waco, Texas. Thousands of visitors. You can see here 5,000 visitors a day. We did fixed 5G at this location and then broadcasted that connectivity over a Wi-Fi network, but saw through that fixed connection with significant capacity, 1.2 gigabits in transmission and actual latency of 9 to 12 milliseconds. So really exciting demonstration that we did down in Waco that translates to retail and government use cases alike. And we can move through the rest of this and give Hitachi some time to present as well.
Matt, I want to thank you very much. Dense Networks, we participated in the Florida Automated Vehicle Conference last week in Tampa. And boy, oh boy, are they all screaming for more network advancement. So that said, the video surveillance and V2X, two of the biggest topics that Dense Networks is following. And I'm excited to have Justin Bean describe Hitachi and particularly the concept of smart spaces, which is really, really impacting connected cities and smart cities. Justin?
Sure. Great. Thanks, everybody. I really appreciate it. So my name is Justin Bean. I'm the director for smart spaces and video intelligence at Hitachi, as Peter mentioned. So when we talk about smart spaces...
Excuse me, Justin. Please advance to the Hitachi slides. Thank you.
Great, thanks. Yeah, and you can go ahead and build this out so we can see some of these animations here. So now with smart spaces, we're looking at how can we make all of these different spaces throughout our cities smart, right? Because cities are bigger than City Hall. They're shopping malls, they're airports, they're transit and traffic infrastructure, they're retail. All of these things that Matthew talked about, that David talked about, are these smart spaces within the city that in the aggregate create a complete smart city. And so we need to make all of those spaces smart. And so when we look at the big picture here, we're in middle of the largest explosion of technological innovation on an exponential curve that humanity has ever seen, right? It took about 35 years for the television to reach about a quarter of the US population. It took about 13 years for the mobile phone to reach that same percentage of the population, and about 6 for the internet. So not only is there an explosion of technology, but there's an explosion in the delivery of that technology and dispersal to the population. And a lot of that is because of this digitalization of the economy. I don't know how many people have a Rolodex on their desk anymore, but most of that has been pulled into Lincoln. It's a digital service that can be connected through your phone, and all that data is sent through. There are many, many examples of the digitalization of the physical world into software, and all of that is going to require the flow of data back and forth. And that's why this is not just one technology like IoT or AI, which on their own are going to have these massive impacts on the world, but it's the convergence of all of those technologies and this technological explosion with the gasoline of 5G thrown on that explosion to make it even bigger and bring it to more and more people. So let me dig into the video aspect here. We see video as the most underutilized source of data that's out there today. Why is that? Because it's already ubiquitous throughout our cities, throughout most facilities. We already have it throughout most of our streets for traffic cameras and in most of our retail environments for loss prevention. But most of that data is simply being streamed back to an area where someone may or may not be looking at it. A human being doesn't have the mental resources to watch 200 different screens and look for everything that's being done. So instead, that video is just being used after a crime occurs or after something happens for evidence. But what we can do with artificial intelligence now is run this on top of video data and transform that data into all of these insights, into real-time alerts, and into IoT data. So as Matthew said, the video camera and video data is now IoT data. And so by combining this with artificial intelligence, combining this with analytics, and proper storage and management of this type of data, we can provide a wealth of different insights in a variety of different use cases. As you can see here, a traffic analysis, being able to tell the difference between a bike, car, truck, or bus, and then count those and look at all of those analytics that you can get from that traffic. We had one city that used this, and they had a huge spike in bike usage in one particular area. They thought that might have been a mistake, but then they went back and looked at the data and realized that there were a lot of restaurants in that area. And so all of those bikes were actually bike delivery people. And so they realized that that was a big part of their local economy, and they needed to support these safer and more ubiquitous bike lanes to support that aspect. People counting. Think about getting the same insights in your retail environment, brick and mortar, that you would get from an online store. That's because you can understand how many people walk past my store versus how many entered, where do they spend time, which products do they interact with, et cetera. And on the right here, you can see a queue detector for more of an operations use case. If we can tell when a line is getting too long, how many people have waited in it, and how long, we can do things like send out another ticket agent or open another security gate at an airport. And also what you're seeing here is privacy protection. So that artificial intelligence can also mask or pixelate people in that data so that we're not exposing any of that personally identifiable information. So there's a lot of ways that we can provide these insights and provide these alerts without exposing personally identifiable information and not getting into privacy issues. Next slide. And so not only are we pulling this data from the physical world, but we need to be able to deliver it for distributed intelligence. So platforms like this is just an example of the Hitachi Visualization Suite, where you can combine systems into a system of systems where you can see unlimited layers of data from IoT data, video data, alerts from some of those video analytics that I showed you, as well as some of the transit vehicles and buildings and other objects that are out there, and overlay that data to find things like correlations and how this data relates so that you can solve crimes, so that you can solve traffic issues or even socioeconomic issues, and overlay things like poverty and economic development, jobs, education, and those types of things to understand how to create a better society and create more sustainability for the people who live in that city. So with the ability to send this out to not only things like desktop, but mobile, imagine everyone in that network having all of the insights they need to make smart decisions about what they do every day. So intelligence is moving to the edge in a technological sense, where cameras are becoming smarter, they have embedded intelligence within them, and they can tell me how many bikes, cars, trucks, or buses walk by, but also moving to the edge in a human network. So human beings at the edge, quote unquote, are also getting more intelligence, and intelligence is moving to that edge. So a lot of cool ways that we can deliver this, and I'll dig into some of these use cases. Next slide. But first I wanted to give an example of some of the different ways that we can use video analytics, and you can go ahead and build this out. I think there's 3 clicks here. That we can use video analytics and that artificial intelligence on top of video data to give us these types of insights. There we go, thanks. So from an operational perspective, all kinds of things like we saw people counting, traffic analysis, parking, detecting queues, analyzing the activity in an area so you know where people are spending time and how much. From a security perspective, things like object detection, facial recognition, intrusion alerts, and then enhancing video in case those devices have been tampered with. And as I mentioned, privacy is a big part of this, so you can automatically protect privacy with things like the Hitachi Privacy Protector on top of that data. And this works for a variety of different organizations, as I mentioned, and that's what makes smart spaces. So let's go to the next slide, please. And I'll show you an example of a transportation use case where we have edge devices on light rail, and so we're able to stream that video back to the public safety officers. So if there's an incident, they can know where it's happening, what's happening there, and then they can run these types of analytics on top of that in order to give them that real-time situational awareness and then real-time alerts on those buses and on those trains, as well as the operational data from the vehicle can all be moved back through these networks. And 5G is really going to increase our abilities to stream that data, and with all that data, we're going to be able to do a lot more with it because of artificial intelligence. So this is a huge opportunity to make the world around us smarter because of our ability to transmit all of that data much faster and be able to do all of these video analytics and artificial intelligence on top of it. Next slide. And you can build this out. I think there's 1 or 2 clicks here. So, you know, stadiums and venues are another place where we, first and foremost, we want to be safe, but we also want the operations to flow smoothly. So in stadiums, for example, this is a project we worked on where we integrated multiple systems throughout the stadium, many cameras, lots of data coming in from them, And from a security perspective, being able to do things like facial recognition and recognize people who would be dangerous to the people there, but also integrate systems like the drone detection and denial. So this is an emerging threat where basically anyone can fly a drone into a stadium with some type of explosive or biochemical agent. But also think about how much money these networks are paying to stream or have exclusive access to the footage from these events and then sell that. And so with a drone, also someone could go in and just live stream on YouTube and make that millions of dollars of spend basically useless and degrade that business model. So a lot of different ways of thinking about this. There's a safety aspect, there's also the experience, and also the protection of different business models. Next slide, please. And I think there's one more click on here, or two more clicks to build this out. So campuses are a big part of the city. That includes higher education, corporate campuses, wherever we have people who are moving around in this area. This is a campus in Australia that became a smart campus through the use of video technology and also things like LiDAR, analytics, and some of the visualization you saw there. So what they're doing is leveraging that video data to understand the flow of students on campus, but also the building utilization. So how is their planning of the usage of classrooms and the uses of those buildings panning out in reality? And is it matching it, or are those students dropping off rapidly? And if so, can they shift that scheduling around in order to make better use of the existing infrastructure that they have, as opposed to building out new buildings? They had one use case where they were considering building out a new building for about, I think, $25 million and $1 million a year operating costs. But with this data, what they were able to realize was that they had existing room that they could shift people around into because the registrations didn't match the actual attendance. And so they were able to push out that investment by 5 years, save $5 million in operating costs, and get a better deal on the financing of that project. So really, really interesting things we can do from this on government levels, but also in private environments and quasi-private, quasi-public environments. What they're also doing is facial recognition in the classrooms so that on test day, they can prevent test fraud, which was a bigger deal than they thought it was. But apparently a lot of people were sending their cousins in or friends in to take the test for them. And with this, they can match the facial recognition with the registration photo, and they can have verification by the teachers too. And another part of this is they're able to share some of this data with the students for student projects and some of the things that they're working on at the university, so those students are prepared for the job market that they're going to enter when they graduate. You know, manufacturing is a great job for many people, but unfortunately for many people that is rapidly being automated, and the cost of manufacturing becoming much cheaper because of that, and is actually creating a world of abundance. So the jobs of the future are going to be about data. The jobs of the future are going to be about the analysis of that data and understanding analytics. And so by exposing this data to those students, they're enabling them to be better equipped for the world that they will face once they graduate. So really, really exciting project here with a variety of different benefits, from the experience to the education to safety and integrity of the education system. So with the last slide, I'll just go over this really quickly. But this is an example at a theme park where we're combining things like video with other emerging technologies like LiDAR. Now, if you don't know much about LiDAR, LiDAR is basically sonar, but with laser beams. So it's pretty cool stuff. And these sensors measure the time of flight of those lasers to give a 3D representation of the world in real time. So we can use that to, again, improve the operational management of that area, but also sense small changes in the movement of machines, because we've got this, binocular vision giving you a three-dimensional picture. And there's no personally identifiable information being captured by this either, because these are laser beams that are giving us about a ½ inch of resolution. So we can get all kinds of movable three-dimensional representations of the world and get alerts if something's not right, or track an individual across an entire event space and stitch together those different LiDARs to get a sense of their journeys and pathways and dwell time without capturing any personally identifiable information. So very, very good use cases here, from stadiums to event centers to cities, traffic, transit, you name it. And all of this is going to be enabled even more by things like 5G, by being able to send this data back to a core server that's running those video analytics, as well as intelligence moving to the edge with more compute, lower costs at the edge, being able to do some of those analytics there and then transmit the metadata so that we can get these rich insights about the world around us and take a data-driven and pragmatic approach to improving safety in our cities, transit and transportation, happiness, which one of our customers in India is actually doing with happiness and global UN Sustainability Development Goals, and then the experience in an environment like retail or a private environment. So many, many really cool ways this data can be used. It's massively underutilized, but thanks to artificial intelligence and 5G and the convergence of all of these new technologies, the world of the future is going to be much more efficient and much more effective at serving our needs and a much safer place. And we're excited to be a part of that here at Hitachi and with the partners that are on this call. So thank you very much.
Great. Thanks very much, Justin. Annette, did you want to facilitate, or can we open up to questions?
Yes, most definitely. Open it up to questions. We probably just need 2 minutes at the very end, but you're good to go.
Okay. Can the group ask verbally, or do they have to type them in?
Probably via the chat mechanism at the bottom of the screen. If you guys have any questions, you can direct them to the panelists, and then we can go from there.
Okay, so can you read them off, perhaps, or let me start with a question for both carriers, Matt and for David. What does it mean, Matt? I'll ask you first, but what does it mean that 5G is coming to a city? Specifically, what should we expect? And the same question for David.
Yeah, so I think that cities at first, what you'll see is partial deployments that are probably in some of the most important areas. Early on for us in the cities that we've deployed in thus far, it's been to enable a lot of these use cases, but those will expand and will become and look a lot much like what you see in our coverage today. But you'll see us prioritize coverage based on where it's needed most and where the use cases can benefit from it most, and then it'll expand from there. Now, one thing I do want to draw just a little bit of attention to is, this doesn't just apply to our commercial network, but we'll have a focus on, public safety and what we do with FirstNet, right? And so there'll be those benefits and capabilities that will drive us and motivate us to expand as far beyond just urban areas to also support rural areas as well.
Okay, so from what I heard there, specific use cases are going to drive areas like smart spaces, and then that will be the beginning of an evolution of that network over time. Is that?
That's right. I mean, less specific use cases and more where we expect specific demand and benefit from that, right? Oh. So you'll see that first, and then it'll expand. It'll expand beyond that based on, like you've seen networks expand for us in the past, right?
Mm-hmm. David?
All right. We do have some questions, just so you know.
We'll give David a chance to answer that one, and then go ahead.
I'm sorry, go right ahead.
Yeah. So, as the 5G technology set evolves here and grows, and the standards become, better defined, I think we're going to see more manufacturers come out with newer devices, and so we'll start to bleed into the mobility world. But initially, the deployments that we're doing are more like our fixed wireless related, so fixed 5G installations. We announced our residential broadband service in Houston as part of the initial rollouts in one of those cities. So that's one of the initial use cases. And then the second is more, as I was saying, with public safety use cases where it's more fixed infrastructure to fiber endpoints for backhaul type of initiatives. So it'll be, and I agree, it's more concentrated in certain areas and then build out over time as the mobility plays start to come into effect.
Please go ahead, Annette.
Okay, one of the questions here is, what are the greatest 5G security threats? And also, how many 5G capable devices are available for purchase today?
Yeah, so 5G devices available for purchase today, we will have in the beginning of next year a mobile hotspot that will be available. It's already been tested. It's already operated on our network. As far as 5G devices, I don't think there's a 5G device in market today, but more representative of coverage that's being expanded and being tested that will have a commercially available devices in the beginning of next year.
All right, here's another one. I see 5G as huge for land-based applications, but with the more broad IoT cases, do you not foresee issues with overall shared bandwidth since our fiber standards are going to remain limited for the current connections?
We certainly don't have that concern. I mean, certainly what we're doing today is deploying the backhaul necessary to support the throughput and the amount of data that we expect to be pushed over the network. So that hasn't been a concern of ours.
Okay, and this last one is for Hitachi. How is Hitachi using AI today, and how will Hitachi preserve the integrity of AI data and devices from cyber threats?
Yeah, so you saw some examples of how we're using artificial intelligence today with a lot of the video analysis, but also the analysis of business data and IoT data. From the privacy aspect there, we talked a little bit about the ability of artificial intelligence to protect the privacy of people in video so that we're not exposing that data. And also these systems often track the usage of the user. And so there's also transparency into how a system like that would be used. And so that if there's a Freedom of Information Act or request or something like that, the public would be able to see how that is being used. So on both sides, you're protecting the privacy on one side and offering transparency on the other. And we think that's a strong aspect of it. From the cybersecurity side, I mean, the entire IoT industry is focused on security. I think it's one of the biggest questions or most common questions that comes up, and one of the most common topics that people are talking about, how to secure these networks and how to secure these devices, and new ways of doing that through a huge variety of different approaches, which I'm not going to dive into outlining here, but there are many approaches to it and many ways that it's being protected. And I'd say one aspect that we need to think about is also resiliency. So, for example, with energy systems or the electronic systems that we all depend on for society today, these things are already the foundation to our technological society, and we need to be able to protect those in addition to the new IoT sensors that are coming out. So I think that ship has already sailed for us being a technologically dependent society, and we need to make sure that all of those things are secure.
Awesome. All right. Well, we probably don't have any time for further questions. We can just wrap up here. First of all, I want to thank all of you, Peter, David, Matthew, Justin. Great presentation. For those of you out there, if you want to get involved with CompTIA, again, this is your global industry trade association. You can join our newest community called Emerging Technologies. We also have CompTIA World Magazine, where you can get a lot of use cases and great information. And then finally, we have our Communities and Council Forum in March in downtown Chicago. You're all welcome to join us. And finally, we have ChannelCon, which will be taking place August 5th through 7th. At the Bellagio in Vegas. So please join us. We'd love to see you, and thank you so much for your time. Have a great rest of your day.
Thanks.